So this is a continuation video from previous video. So we will discuss about how the stomata open and how stomata close. Okay, so you may refer to digital textbook biology KSSM published by KPM, and also refer to the module given to you lah. Okay. Alright, so we will look at the module. This is the module actually, okay? And this diagram is coming from digital textbook KPM. Okay. Alright, so first you might want to study the diagram, okay? You can see here ada gambar, okay? Ada gambar K+, you can see right here, K+, dia tunjuk. And then K+, enter. Nampak tak? K+, enter. Dan selain K+, you juga nampak water move. And then bila K+ masuk, water pun masuk juga dalam gut cell. Now the stomata open. Okay, stomach open now. So what is happening actually? Macam mana K+ tu masuk menyebabkan gut cell membuka stomata, dan kenapa H2O pun masuk juga? Kita nak fahamkan yang itulah. So actually here underneath the diagram, okay, ada satu guideline to awak. This will be the answer in an exam. If the question asks you, explain how stoma open, let's say lah, and let's say dia provide 8 mark, okay, allocated 8 mark lah for this question. So what should you write about this? Ada 8 sentences, okay. So this will be the sentences lah, F1 sampailah 8, okay. Alright, so before I start explaining about this, I would like to highlight lah, there are 2 factors. Factor 1, factor 2. Factor 1, it talks about light. Factor 2, it talks about K+ ion. Okay, so let's look at the explanation. Okay. Dekat sini sebenarnya, ini from textbook dekat sini, this is the first factor that initiate the opening of stomata. Second factor yang menyebabkan stomata boleh terbuka juga disebabkan oleh yang tadi tu, light. So this is the second reason lah, second factor that initiate this process. So let's talk about the second factors first lah. Okay, so we talk about the presence of light here. Okay, bila waktu siang ada cahaya kan, cahaya matahari, ataupun waktu malam you boleh juga provide cahaya mentol ke bulb kan, light from bulb pun boleh juga, okay. Tapi generally kita cakap pasal sunlight lah. Now, when there is a presence of sunlight, okay, photosynthesis does occur. Everyone agree this, right? Okay, so apakah produk photosynthesis? When we talk about photosynthesis, you already know photosynthesis, the product of oxygen and also glucose. Okay, oxygen keluar melalui stoma, tinggallah glucose di dalam plant cell, dalam leaf lah. Okay, so glucose ni akan jadi apa? This glucose will be changed into sucrose. Now you come across another word which is sucrose. So glucose tu dia bertukar bentuk jadi sucrose. Sebab glucose ni very reactive, okay. Kalau simpan dalam bentuk glucose, takut use up, okay, without control lah. So to be stored, it must be changed into sucrose. Now dah tukar bentuk sucrose, dia tak reaktif, non-reactive form. So dia boleh simpan lah, boleh travel, nak hantar dekat stem boleh, dekat root boleh. Okay, dia tak reaktif. So dia boleh maintain bentuk dia sucrose sepanjang jalan. So now sucrose dalam gut cell, okay, sebab hasil fotosintesis yang baru berlaku, banyak pula tu, okay, sucrose ni meningkat. Okay, concentration of sucrose meningkat dalam gut cell. You already learn in form 3 about the hypotonic, remember solution kan? So bila sucrose banyak dalam gut cell, water macam mana pula? Water akan kurang. Yes. So water potential will decrease. Dia vice versa. Kalau sucrose ni solute. So kalau solute ni meningkat, water potential akan kurang. Dia memang automatically. Okay. So apa yang berlaku waktu tu dalam gut cell ni, dalam gut cell ni, kita tulis kat sini sikit. Dalam gut cell ni, water kurang. Ni water Water dah kurang. Tapi dekat sel sebelah ni, kita panggil dia adjacent cell. Adjacent cell sebelah. Dekat adjacent cell ni, water banyak. Okay. So, dekat adjacent cell ni, high water potential. Dekat dalam gut cell, low water potential. Bila ada concentration gradient, okay, satu tempat yang high water potential and satu tempat lagi low water potential, the water molecule will diffuse, okay, from high water potential region to low water potential region. And that's why you are seeing this diagram. You nampak sekarang ni H2O masuk daripada adjacent cell masuk dalam gut cell. Sama juga, nampak? So, itu menyebabkan, okay, the water molecule can move ataupun diffuse from from adjacent cell into the gut cell by osmosis. Itu menyebabkan the gut cell becomes turgid and curve outward. Okay, bila gut cell ni, sebenarnya bukan gut cell saja, any plant cell, kalau ada air masuk banyak dalam tu, the vacuole will enlarge. Okay, and then dia akan push the plasma membrane against cell wall. Kalau you still remember lah, chapter 3. Okay, plasma membrane. Cuma specialnya gut cell ni, bentuk dia bean shape. Okay, kalau you tengok kat sini, bentuk dia bean shape. Macam ni, bentuk macam ni. So, bila dia turgid, dia membuatkan stomata tu terbuka di tengah-tengah. Stomata tu yang ni lah. Ni, stomata terbuka. Sebab bentuk dia, gut cell ni bentuk dia bean shape. So, bila dia become turgid, dia curve outward. And this is why stomata open. Macam tu. Okay, this is the first factor. So, apa yang you all boleh buat, pergi transfer dekat dalam ni. So, presence of light. Tadi ada presence of light. You cakap tadi, in the presence of light. So, apa yang you buat, boleh masukkan terus. Yes. Presence of light, yes. Saya buat tick sebab susah nak tulis. Saya tak ada pen sekarang ni. So, photosynthesis happen. Yes, bila ada sunlight, photosynthesis happen. So, apa jadi pada concentration of sucrose in gut cell tadi? Remember? Increases. You tulislah increases. Okay. Lepas tu apa jadi bila concentration of sucrose increases in gut cell? Okay, kat sini korang boleh jump pergi dekat water potential E4. Water potential in gut cell. Bila sucrose meningkat, water potential automatically akan kurang. Tadi kita dah bincang tadi kat sini kan. Bila sucrose tadi high, tengok balik kat sini. Dia tengah loading. Okay, without wasting our time, kita proceed kat sini lah. Dia tengah loading tadi tu. Okay, so dia kalau concentration of sucrose ni meningkat, okay, water potential automatically akan menurun. Macam tu. Okay, so sambung pula E5. Water potential on adjacent cell, kalau kita compare dekat sebelah tadi tinggi, dekat dalam gut cell rendah. Okay, dekat adjacent cell tinggi. So bila ada dua water potential berbeza, akan ada movement of water molecule. So, akan berlakulah osmosis. So, from where to where? Dari mana ke mana direction of osmosis? From tempat air yang banyak apa tadi? Adjacent cell. Dia akan bergerak. The water will diffuse from adjacent cell into gut cell. Sorry, I struggle so much to write this letter. Because I don't have pen right now. Okay, so there is water movement. There is osmosis happen. So, condition of gut cell tadi macam mana tadi? Ingat tak perkataan dia? Turgid and curve upward. Turgid, curve upward. So, you salin balik kat sini. Tulislah elok-elok. Okay, turgid and curve outward. Macam tu. Okay. Alright. So, condition of stoma tadi apa? Open. Macam tu. Okay. Now let's look at the second factor, which is about the K+. Tadi yang pertama kita cakap pasal sunlight, ni kita nak tengok K+ ion. So kita pusing kat sini, kita scroll kat sini. Okay, ini second penyebab. Okay, kenapa gut cell boleh terjit, dia boleh curve outward menyebabkan stomata open. Okay, tengok kat sini point number 1. Potassium ion enter the gut cell. So potassium ion tu dah masuk gut cell. Tengok gambar ni, tengok arrow yang warna merah tu. There is a movement of K+ ion entering the gut cell. When the potassium ion enter the gut cell, it make the solute potential increases even more. Kalau tadi dia dah meningkat dah, dia dah dekat sini kat sini concentration of sucrose increases very high. Yang ni make it worse lah. Solute potential increases. Solute ni it means sama macam concentration of sucrose. Okay, but this one referring to potassium ion lah. Okay, so solute potential increases. So boleh pindahkan masuk kat sini. Solute K+ ion uptake by cell, yes. Solute ion increases. Lepas tu what's next? Sama je, bila solute increases, automatically water potential decreases. Dalam gut cell water potential decreases. Tapi apa jadi pada water potential dekat adjacent sel luar tu? Macam yang kita bincang tadi, dalam gut cell water potential decreases, tapi dekat sel sebelah dia masih lagi high. So bila ada dua difference of water potential, satu tinggi, satu rendah water potential, water will always move from high water potential region to low water potential region by osmosis. So dekat sini sekali lagi water move. Okay, dia macam confirmation lah, dia macam confirmation point lah. Water, direction of water, so this is true lah, from adjacent cell, okay, dia masuk dekat gut cell sekali lagi. So even more water diffuse through osmosis. Okay, so the cell become more turgid right now. Okay, dan dia curve upward lah, dan stoma open. Okay, so right now kita dah habis bincang 8 ayat, okay, to explain the mechanism of stomatal opening. So untuk stomata closing, what should you do is you just reverse the argument lah kat sini. Kalau yang ni presence of light dia, sekejap kalau kat sini presence of light dia, kita tick kat sini absent lah. Okay, just put cross absent. Yang ni photosynthesis happen? No. Okay, concentration of sucrose concentration of sucrose in gut cell increases. Kalau kat sini kita kena tukar, decreases. K+ ion uptake by the cell? No. You just reverse argument dia. Kalau yang E3 ni, solute potential increases, kat sini decreases. Water potential in gut cell decreases, kat sini high. Terbalikkan saja. Water potential on adjacent cell increases, kat sini kita terbalikkan, kat sini decreases. So you just reverse what's here. Okay, kat sini dia pointing upward kan, dia increases, kat sini you reversekan saja, decreases. Yang ini pula sama. Yang ni from AC pergi ke GC, daripada adjacent cell pergi kat gut cell. So kat sini you terbalikkan sahaja, from gut cell pergi dekat adjacent cell. Okay, this is direction of water movement lah, osmosis lah. Condition of gut cell, kalau tadi ni kat sini dia turgid, yang ni dia turgid. Okay, you guys tengok ni, yang ni turgid. Okay, yang ni mestilah terbalik daripada turgid. So kita tengok apakah istilah dia. Kalau dia tak turgid, dia become flaccid. Ni kat sini flaccid. Nampak, flaccid. So tulislah kat sini flaccid. Flaccid. And stomata kat sini close. Close like that. So you just have to understand and then memorize all these 8 sentences to explain the mechanism of stomata opening and closing. Cuma jangan confuse lah. Yang ni opening, yang ni closing. So ingat satu saja, yang lain tu you boleh reversekan saja dia punya argument dia. Okay, this question bawah ni, Fatimah did not water her balsam plant for a week. Explain the condition of stomata on the balsam plant. So ini ialah soalan yang berkaitan dengan topik yang ni lah. Okay, fresh plant versus wilted plant. So you can see here when plant lacks of water, okay, the gut cell become flaccid. So bila gut cell flaccid, apa tadi jadi pada stomata tadi? Stomata close. So no matter what, okay, no matter what, ada cahaya matahari ataupun ada K+ ion ke tidak, okay, tapi kalau gut cell tu dah become flaccid sebab air tu tak cukup, transpiration is too high, still the stomata close. Okay, alright. Okay, the last part is the rate of transpiration. Kenapa transpiration tu penting? Okay, boleh baca dekat bahagian sini. Okay, this one. Okay, this is the explanation why transpiration is very important. Boleh baca. And then this explain about the rate, the factors affecting the rate of transpiration. So ada 4 lah factor. Number 1, light intensity. So you guys boleh tengok graph ni. As light intensity increases, the rate of transpiration increases until it become constant. And kenapa dia constant? Disebabkan ada faktor lain yang menjadi limiting factor. So relative air humidity, yang ni temperature jadi limiting factor, relative air humidity jadi limiting factor, air movement pun jadi limiting factor. So that's why lah graph jadi constant. Kalau macam ni pula air humidity ni the content of moisture in the air, okay, kelembapan udara lah, okay. So kalau udara, banyak water vapor dalam udara, transpiration akan jadi rendah. That's why lah macam ni. As you see, as the air humidity increases, the rate of transpiration decreases. Okay, explanation dia ada kat sini. Sebab bila ada banyak sangat water vapor, water vapor dekat dalam udara yang sedia ada, this water vapor will block the water vapor inside the leaf to escape. Okay, kalau dekat udara kurang water vapor, okay, so water vapor inside the leaf can escape easily through the stomata. That's the explanation lah. This one is about temperature. As the temperature increases, the rate of transpiration increases. Sebab apa? Bila temperature increases, kinetic energy increases juga. Okay, so water will change from liquid into water vapor in faster rate lah. So air movement, kalau ada pergerakan udara, lagi cepat transpiration berlaku. Okay, itu sahaja.